A mole? What is that?
So, here's a hypothetical percent yield problem for you to try. But what do? Step 1. If you are at all intimidated by the problem, completely disregard the quote-unquote big words and instead concentrate on creating an equation. Step 2. Once you have your equation, always make sure that the equation is balanced. And if it isn't already so, then you must balance it yourself. Aha! Now this example is balanced.
Now do a mass-mass calculation to figure out how much lead iodide you should theoretically produce in this experiment. Since you're given 1.82 grams of lead nitrate, just use that. Start with the given amount of lead nitrate and convert to moles of lead nitrate. Once you do that, you can then convert to moles of lead iodide, and then ultimately to grams of lead iodide. This is now the perfect time to test your comprehension on the previously mentioned molar mass. Again, if you're given a substance in grams, you need to divide by the gram formula or molecular mass in order to get it to moles, as seen in the second and fourth parts of this equation. Also, you can now see just how useful moles truly are in conversions such as this. The result of this equation is how much product, or in this case, lead iodide, you should produce in theory. You now know how much lead iodide you should produce in theory, but how much will you truly produce in this experiment? In this case, pretend as if you have both conducted the experiment and produced 1.77 grams of lead iodide. How close were you to what you should have gotten? Well, that's what percent yield is for. So, step 6, use the percent yield equation. Take your experimental or actual yield in grams and divide it by your theoretical yield that you just calculated. Then multiply it by 100 for percentage value. In this example, plug in 1.77 grams of lead iodide for your experimental value and 1.82 grams, which you calculated, for your theoretical value. The result is your percentage yield. Woot! But what does this number mean? Well, in layman's terms, it tells you how on, or how close, you were to the theoretical value, the expected value. In this case, that 97.23% would be considered an excellent percent yield.
If the percent yield that you calculated is significantly different from this one, make sure you go back through your steps and check for any experimental, human, or even round-off error. Just remember, if you're having any trouble whatsoever, you can always rewind and replay this video. And above all, thanks for watching.